Hello, welcome back to linear algebra. Any Anki flashcards do? No. So what will we do? We're gonna grade my problems from yesterday. Then I'll check in, and then we'll continue doing more practice problems today. So I'll be back in a bit. I got all the problems right from yesterday. Can you believe that? Let's go. Square root of matrix square root correct. Finding unknowns in matrix correct. Solving for a linear system that had just constants correct. And then determining how many 3x3 matrices I can find in which satisfy an equation that was given. All right, so now we're going to continue working, so I'll be back in a bit. All right, guys, we got to the proof problems today, or problem. I really am trying to do my best on this proof. I might actually be able to pull out a proof, a really shitty one maybe, but I think we're doing pretty decent. We're trying to prove that if A and B are n times n matrices, then the trace of AB plus the trace, or equals the trace of A plus the trace of B. I'm basically saying, so if A and B are n times n matrices, then A and B are square matrices of the same size. If A and B are square matrices of the same size, then A times B is the size, or is the size of n times n. If AB is essentially a square matrix of n times n, then the trace of AB is AB 1 1 plus AB 2 2 plus dot 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 plus AB and n. And then if AB, this is all this. Another way to state that is the trace of AB is A11 plus, or times B11 plus A22 times B22 plus dot 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 plus A times B n. And if but this is where the part is, I'm pulling another different true statement from A and B or square matrices, saying that the trace of A is the sum of the entries of the central diagonal, and the same can be said for B because they're square matrices. So then another way to state that is this, and then I'm gonna write these two are equal, or this plus this equals trace of A plus B, and then we can say that the trace of this is equal to this, and then these are equal to each other. Now I'm trying to find a way to stitch these together. I don't know. Anyway, we got 31 done, which was basically just an algebra problem. Manipulating two equation, two equations, substitution, and algebraically rearranging them. 33 was kind of a word problem about what a matrix represented. And then, yeah, 35 was the proof, so. I don't know, we got all the problems right yesterday. We're kind of doing a proof for the first time. We'll see if we got the other two right, but yeah, I think we're starting to get some things are starting to click. So that's it for today. I'll talk to you later. See ya.